Hello, everyone. EJA Academy is here. I'm Hussein. Amir is here with me today.
Hello.
Hey, Amir, what's up?
Hey, good. How are you?
Good, good. Cheer up. I have a problem for you.
Yes, that's why you are so happy.
Yeah. Yeah. Okay, this is another integral.
Mhm.
This is an indeterminate integral, and as you can see on the screen, the expression inside the integral is t times secant squared of 2t dt. So it's a polynomial function
Mhm.
multiplied by a trigonometric function.
Mhm.
So please help us find the
Yes,
answer for this problem.
yes. Here, I believe similar to the last problem already solved.
Mhm,
We have two functions multiplied by each other,
mhm.
and so here we have a function of t, and then the other one is secant squared of 2t.
Right.
So in such circumstances, it's more efficient and better to use the integration by part.
Mhm,
So as we know, the integration by part is the relationship for that is u dv
mhm.
equals uv minus integral of v du. So this is called integration
By
by
part.
part.
U and V are two different functions
Correct.
here.
Yes. Yes.
Yeah,
Yeah.
both could be in terms of x or t in this case, for example.
Yes. Yeah. Here we have in terms of t.
Mhm,
So I guess it's easier to choose this one as u and this one as the v.
mhm.
So if I choose u equals t, then if I actually take a derivative of both sides, I get du equals dt.
Right.
So um, the purpose is, is to have this form and also this form.
Right.
Yeah. So for the second one, for the second function, uh, dv is equal to secant squared of 2 times t
Mhm.
dt. So we want to obtain a v. So
Do you remember the integral of secant squared or the derivative of?
yes,
Yeah.
yes, I believe so. So as aside here, I'm going to
Mhm,
change the color. So integral of secant squared of um, x dx is equal to tangent of x
Yes.
plus c.
Mhm,
And since here we have a coefficient of 2 times
mhm,
t,
mhm.
so it's going to be, I mean, we are going to inverse
Right.
that coefficient outside the integral. So
Yeah.
uh,
So you
that's
need to
basic.
add 1/2
Yeah,
multiply.
1/2.
Yeah.
Yes. So due to that, um, it's going to be 1/2 of tangent of x. I don't write c for now.
Okay. Instead
Uh,
of x, you should write
oh,
2t.
sorry.
Yeah.
Correct.
Yeah, because our variable here is not x, it's t.
T.
Yeah,
Yeah.
2 times t.
Yes. 2 times t. Correct. 2 times t. So yeah, perhaps it's better when you want to have an aside function, you
Mhm.
don't change the variable. You
Right.
just
Yeah.
you just be consistent. Yeah.
Yeah.
So if I call this integral as I,
Mhm.
I is equal to u times v, which is u is here, t, and v is this one. So it's going to be 1/2 of t tangent of 2t. That's u times v
Mhm.
minus v du. So it's going to be v 1/2 of tangent of 2t, this one, times du, times
dt.
dt.
Mhm.
So let me call this one I2, integral number 2, something
Okay.
like that. So let me write one line below. I2 is equal to, I can actually get 1/2 outside out of the integral.
Okay. Yeah.
Tangent of 2t dt.
Mhm. Do you
So
recall the integral of tangent?
yes, let me just write it as aside here.
Mhm.
Integral of tangent of t, I don't change the variable here.
Yeah, that's a good idea.
Yeah, dt
Mhm.
is natural logarithm ln of absolute value of secant of t,
That's correct.
of course, plus the constant.
Yes.
So yeah, again, we have a coefficient here. So when we have that, so it's going to be the inverse of that coefficient outside the
Mhm.
integral. So change the color here. 1/2 of the inverse of this one.
1/2.
1/2 times, then
ln of
yeah,
secant.
ln of secant of 2t. So
Okay.
plus constant. It's going to be,
So you substitute that into
yeah,
the expression above.
correct.
Mhm.
This is 1/4.
Mhm.
So if I just call this one relation number 1 and call this one relation number 2, from relation 1 and 2, if we consider both of them together, we get I is equal 1/2 t times tangent of 2t minus 1/4 ln of absolute value of secant 2t plus constant. Yeah. So I believe that's the answer.
Right. Yes,
Because
that's
yeah,
correct.
we call this one I, and I is our function on the top.
Right. Okay. Yeah, sounds good. Thank you, Amir. Appreciate.
Yes, sure, absolutely.
Yeah. So this is also another application of integration by part. So in this example, we had a polynomial function multiplied by a trigonometric function, and so this is a good candidate to use integration part by part, and then you assume the polynomial function as u, and you took the derivative of that function. This way, you reduce the degree of the polynomial.
Yes.
And that help you know, to solve,
Yeah.
to make it easier to solve, because as you see on this, on the third line, I see I2 is just a trigonometric function. You
Yes.
basically, you got rid of the
Yeah.
polynomial function.
Correct.
Yeah. All right. Sounds good. Thank you so much. And
Sure.
for the
Absolutely.
viewers, that is all for today. And if you have any questions about this example, please leave a comment down below this video. We get back to you. And also, please consider subscribing to our channel. This way you support our effort, and also hit the notification bell so you get notified about future videos. Till next time, cheers everyone. Bye.
Thank you. Bye.
Thank you.